Children, I would like to introduce you to a very important topic in triangles, namely altitude and median, which you should never be confused or intermix both these concepts. Altitude and median both pertain to each side of the triangle. Every side of a triangle bears an altitude and a median. The side AC, maybe if it is 10 centimeters long, if it is divided into two equal parts and that line goes on to join the vertex of the opposite side, that happens to be the median. Median joins the midpoint of a side to the opposite vertex of that triangle, and each side will bear one median each, and that will join the vertex that is in the opposite side. Now coming to the altitude, altitude is the perpendicular. It can be anywhere on the side, not necessarily the midpoint, anywhere. The altitude can be anywhere, but it cuts 90 degrees angle at the base. So I can draw an altitude, it would be 90 here. I can draw an altitude, it would be here, an altitude, and this will be 90. So basically every triangle has 3 altitudes and 3 median. The point is median, the shortcut, then the trick is M carries the M, the midpoint, and altitude, as you can see, the free translation of the word altitude means height, and you can see that height itself bears the perpendicular. So these are the tricks to remember altitude and the median. So altitude of a triangle corresponding to any side is the length of the height, of the perpendicular distance from the opposite vertex to that side, and median of the triangle is the corresponding to any side is the line segment joining the midpoint of that side to the opposite vertex. This is the midpoint. This happens to be the median. This is the altitude. Children, particularly for the isosceles triangle, the altitude bisects the vertex as well as the base. Now if this is 5 centimeters, this will be 5. If this is 30, this will also be 30 degrees. This is what I meant to say. This is the property of the isosceles triangle. Coming to an equilateral triangle, you can see that if I drop a altitude, a perpendicular onto the base, again this is also bisecting my base and bisecting the vertex. This will be 30 and 30 degrees. From this we find out that this particular altitude is also playing the role of median in an isosceles triangle. One altitude is playing the role of the median, whereas in an equilateral triangle all the 3 altitudes are also the media of the triangle. 3 altitudes are the 3 medians of an equilateral triangle, whereas in an isosceles triangle only one altitude plays the role of the median, because it also bisects the third side, which is the definition of the median. And here you can see the other 2 altitudes cannot play the role of the median. Only one altitude becomes one median in an isosceles. This is the chief difference between these 2 triangles, whereas for the all other triangles, altitude is totally different from the median. For an equilateral triangle, the altitude is equal to the median and the length of both is same. All the three altitudes and median, the length is one and the same. If I have this as 6 centimeters, this will be also 6 and this will be also 6, and they are both the midpoint as well as the perpendicular. Whereas coming to the isosceles triangle, only those two altitudes will be equal length, which are connected to the equal angles. The vertex holding the equal angles, only those two altitudes will be of equal length. This is most important point. Whereas the longer altitude, which is bisecting the angle as well as the side, we have known that this is both the altitude and the median of the isosceles. Please don't confuse yourselves, children. This only one altitude becomes the median, and this is the longest of these three. So as you can see, every word that I have spoken here becomes a theorem, and this herein there is another theorem which says sum of the three altitudes, the lengths of the altitudes of the triangle is less than the perimeter of the of any triangle. And we can also give the converse of this, stating that the sum of three sides is greater than the sum of three altitudes, and the same holds good for the medians also, the medians of the triangle. And for a right angle triangle, you can see that this is one altitude, and here I can drop, and herein I can drop another altitude. But what about the third altitude? The side itself becomes the altitude, because this is the perpendicular. Hence, for a right angle triangle, one of the side becomes the altitude, the third altitude. And here you can see this is an obtuse angle triangle. If I drop a perpendicular, I can drop it here, and if I choose to drop a perpendicular, this will be here. Now what about the third altitude? It will be outside the triangle. So this is the third altitude of this triangle. So you can watch out for an acute angle triangle, isosceles or equilateral or a scalene. All the altitudes lie within the triangle, whereas for an obtuse it is outside the triangle. For a right angle it is on the triangle. That is what we say. There are many theorems related to altitudes and median. Not only these three things, there are also theorems related to two altitudes and two median, and we shall keep on studying them in the examples following herein.